Good? All right. So this is a demonstration project for MAE 535. This is Dr. Buckner's design of electromechanical systems at North Carolina State University. Today we're going to be talking about how an ignition coil works. An ignition coil can be thought of as a transformer that has a primary and a secondary coil. The primary coil has low resistance, and the secondary coil has higher resistance and more turns. So these coils are actually wound around the same iron core, and so when a current is induced in the primary coil from hooking it up to, say, a 12-volt battery on a car, it produces a magnetic field through that coil. When the current is turned off on this coil, the magnetic field collapses, and when that magnetic field collapses in the secondary coil, that creates a very, very large voltage spike in the secondary coil, generally in the order of 10 to 40,000 volts, or excuse me, 10,000 to 40,000 volts, which is enough to jump a spark gap of about 1 centimeter and 1 millimeter. So today we're actually going to be looking at this demo that I have here, and it's set up so that we have an ignition coil from a car here. We have 200 or 120 volts coming into the outside here, run into a power supply down here that converts the 120 down to about 19 volts or so. Then it's run from there up to through a switch that controls basically we can control the current coming into the coil, to the primary side of the coil, through this switch on the top here. And then it runs into the primary coil here, and then out of the primary coil on the other side. And when it comes out of the primary coil, it runs through this ballast resistor, which effectively limits the amount of current that can come through the coil, because this coil has about 0.6 ohms. So if we put 19 volts on it, we'd be pushing 30-something amps, which would blow this thing out. So it comes through the ballast resistor, which keeps it from pulling too much current, and then runs up to the power supply. So we have effectively a loop coming from the power supply through the coil up to the switch for the primary side. Then the high side, or the secondary side, what comes out of this top here, is connected up to the terminal on the top here. It comes out here, and then this other side is connected to ground again. So what we should see is when we take and plug this thing up, and we have box closed here. When we plug this thing in and we push this switch down, it should energize the coil, and then when we release the switch, that's going to effectively turn off the current to the primary side, and we should get that high voltage spike, and then we should see a voltage, see a jump across these terminals here. We should be able to see a spark. So let's see if that actually happens. Plug this thing in here. So I've got my 120 volts coming in. It's always nice to see the light come on. Turn this on here. So this actually puts power into my switch, but the switch is closed right now, so it's not on. So if I push this switch down, I'm energizing the primary coil, and then when I release it, I see the spark jump through. I'll do that again for you. And we'll do it one more time. So you notice that, like I said, when you press down the coil, it's energizing, but when you release it, that's when you see the high voltage spike on the top here. So, and that's how generally an ignition coil works from a very elementary standpoint. Thank you.